Welcome everyone! You've got the D685 OA exam coming up and you want to fully prepare for it. Well, we're going to help you with it. We built a free question bank for the D685 OA exam. Preparing for an OA is no joke, so our guides and practice questions are completely free. With over 100 plus success stories, we have proven our videos will help you pass your exam on the first attempt. In this video, we will cover questions from prompting techniques, AI ethics, machine learning, data processing, AI technologies. So, let's get started.
Question 1. A technology manager at a logistics firm is preparing a briefing for executives who want to understand why artificial intelligence has become central to modern operations across many industries. Which key benefit is most consistently associated with artificial intelligence in these settings? Your options are A. Implementing reliable common sense. B. Processing data in real time. C. Performing fully independent reasoning. D. Eliminating the need for oversight. Which one is it? Pause the video if you need more time. The correct answer is B. Processing data in real time. B is correct because artificial intelligence platforms can ingest, analyze, and act on streaming information as it arrives, enabling fast insights and responsive decisions across logistics, finance, and similar operational settings. A is wrong because common sense remains a persistent weakness for AI. Machines lack the lived experience and everyday intuition that humans use when making informal, context-driven judgments about ordinary situations. C is wrong because fully independent reasoning requires general intelligence, which is still theoretical. Current AI follows learned patterns from training data rather than reasoning from first principles the way a person does. D is wrong because responsible AI deployment still requires strong human oversight. Models can produce errors, biased results, or unsafe decisions, so monitoring, review, and accountability remain essential at every stage. So why does AI matter so much in modern operations? The answer comes down to one thing: speed on live data. Before the 2000s, most business data sat in monthly reports reviewed after the fact. Then credit card networks, e-commerce, and sensor-heavy logistics fleets started producing streams no analyst team could ever read by eye. Two modes matter here. Batch processing collects data over a window and analyzes it later. Real-time processing scores each event as it arrives and acts in milliseconds. Streaming AI is that second mode, and it's what most headlines are really describing. In practice, a trained model sits inside the live pipeline. Events flow in, the model scores each one in milliseconds, and the score triggers an action: a fraud decline, a rerouted truck, a dynamic price. The customer feels nothing, but the decision has already been made. On the exam, the right answer uses words like streaming, real-time, or continuous. Wrong answers overclaim in promising common sense, full autonomous reasoning, or zero oversight. Real-time is the hill this technology planted its flag on. Question 2. A company that specializes in personal financial advice wants to implement artificial intelligence to improve internal business processes, speed up document review, and help advisors spend more time with clients. Which task is an AI system well suited for in this specific context? Your options are A. Summarizing lengthy client documents. B. Reading client facial expressions. C. Eliminating all portfolio risk. D. Inventing brand new products. Take a second. Which answer would you pick? The correct answer is A. Summarizing lengthy client documents. A is correct because AI excels at scanning long reports, statements, and disclosures and producing concise summaries that highlight key figures and terms, freeing advisors from slow, repetitive reading tasks. B is wrong because reliably interpreting human facial expressions in real meetings is beyond current AI capability. Emotion recognition tools exist but are shallow, error-prone, and not suited for financial decisions. C is wrong because no system, human or machine, can eliminate portfolio risk. AI may help model and manage risk, but markets remain uncertain, so risk reduction is the realistic goal here. D is wrong because product creation involves regulatory, legal, and strategic judgment that AI cannot own alone. Models can suggest ideas, but humans design, approve, and launch any new financial product. So why is summarization the killer app for AI in financial advisory? Let's look at the deeper pattern behind this question. Financial advisory has always carried a reading bottleneck. An advisor serving 50 households digest quarterly statements, prospectuses, and trust documents, thousands of pages of dense legal prose every quarter. 3 reading tasks dominate here. Extraction pulls a specific data point. Summarization compresses a long document into something skimmable. Comparison lines up documents to show what changed. Modern AI handles all 3 well. Morgan Stanley's 2023 rollout is the textbook example. 16,000 advisors got an internal assistant that summarizes portfolios, drafts messages, and extracts key points from research, giving advisors back hours each week for actual client conversations. The pattern is simple. If the task means reading a stack of paper and producing a shorter stack, AI wins. If it asks the model to feel, guarantee, or invent, that's where AI still loses. Question 3. In order to improve its social media platform, a growing company is starting to incorporate artificial intelligence into the platform's core functionality and content handling. Which task is well suited for AI in the context of user-generated posts and images? Your options are A. Backing up all profile data. B. Interpreting every cultural nuance. C. Extracting text from images. D. Fully understanding user emotions. Before I reveal it, which one do you think is right? The correct answer is C. Extracting text from images. C is correct because optical character recognition is a mature AI capability. Platforms routinely pull text from memes, screenshots, and photos to improve search, moderation, accessibility, and recommendation features for users. A is wrong because routine backup of profile data is infrastructural work handled by storage systems and scheduled jobs, not a problem that needs artificial intelligence or machine learning techniques to solve. B is wrong because cultural nuance often depends on context, history, and lived experience. Current models miss subtle meaning, sarcasm, and regional references, so full interpretation is not a reliable AI task. D is wrong because user emotions involve inner states that cannot be fully inferred from text or pictures. AI can estimate sentiment, but claiming deep emotional understanding overstates what the technology delivers. Let's talk about why optical character recognition keeps showing up on exam questions about AI for social platforms. A solid AI use case has to pass 3 tests. It has to be a narrow task. It has to work at scale. And it has to replace slow human labor with no loss in quality. OCR hits all 3. 3 zones matter here. Mature tasks like OCR work reliably today. Developing tasks like sentiment scoring work sometimes. Frontier tasks like sarcasm and cultural nuance still fail often. Exam questions about what AI is good at point straight at the mature bucket. Inside a platform, each uploaded image passes through OCR and gets a text string attached. That string powers search, catches policy violations, and feeds screen readers. Meta runs this across billions of images a day. So if an exam question mentions text and images together, think extraction first. And if an answer promises deep cultural understanding, that's the distractor. Question 4. A software vendor is developing a new integrated development environment for programming teams and wants to incorporate artificial intelligence features that genuinely help engineers work faster. Which specific software task is particularly well suited for AI assistance in this context? Your options are A. Defining every code variable, B. Specifying the full project structure, C. Performing all end-user testing, D. Explaining code errors to developers. What's your answer? Commit to one before I continue. The correct answer is D. Explaining code errors to developers. D is correct because AI coding assistants are strong at reading stack traces, identifying likely causes of failures, and describing fixes in plain language, helping developers debug faster without scanning long documentation. A is wrong because naming and defining variables reflects design intent that belongs to the developer. AI can suggest names, but blanket assignment of all variables would obscure meaning across the codebase. B is wrong because overall project structure depends on architecture decisions, team conventions, and business needs. Those choices require human judgment and cannot be fully specified by a code assistant alone. C is wrong because realistic user testing requires human behavior, accessibility checks, and business validation. AI can run automated test suites, but it cannot substitute for real end users exercising the product. Let's step back and ask what a coding assistant is actually good at, because the answer is narrower and more interesting than it first appears. Coding assistants live on a spectrum. On one end, they autocomplete obvious lines, saving seconds. On the other, they try to design whole modules and usually get the architecture wrong. The middle, explaining errors, is where they save minutes or hours. Under the hood, the assistant takes the stack trace and surrounding code, runs it through a model trained on huge amounts of public code, and returns a short explanation plus a suggested fix. The model narrates. The developer decides. On exam questions, correct answers stay in this narrow professional lane. Wrong answers overclaim, giving the AI authority over project structure, user testing, or business intent. Watch for options that put AI in the architect's chair. A coding assistant is a narrating senior engineer without the salary. If an answer puts AI in the debugger's chair, it's usually right. If it puts AI in the architect's chair, it's wrong. Question 5. A product team is evaluating several generative AI tools and reading user feedback about why some feel more useful than others, particularly for writing and creative work. Which benefit comes with well-designed generative AI interfaces compared with poorly designed ones? Your options are A. Users can specify parameters and constraints. B. All output errors are filtered out. C. Users avoid exposure to misinformation. D. Every user sees unique output. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is A. Users can specify parameters and constraints. A is correct because good generative interfaces expose controls like tone, length, audience, and style. Those parameters let users shape responses precisely, which produces more useful output than vague, open prompts alone. B is wrong because no interface can filter every error from a generative model. Good design reduces mistakes, but hallucinations and inaccuracies still require user review and independent fact-checking after generation occurs. C is wrong because interfaces cannot guarantee freedom from misinformation. Models still draw on imperfect training data, and even well-designed tools can produce confident-sounding content that turns out to be wrong. D is wrong because uniqueness is not a guaranteed property of interface design. Similar prompts often yield similar output across users, and novelty depends more on the prompt itself than the wrapper. So why do some AI tools feel sharp while others feel frustrating? The answer almost always comes down to one thing: the control surface. Think of it like a camera. A point and shoot gives you one button and hopes for the best. A real camera exposes aperture, shutter, and ISO. And suddenly, you can actually shape the photos you want. Good generative interfaces expose three kinds of controls. Content parameters like tone and length, behavior parameters like creativity level, and context parameters like uploaded documents. Poor interfaces hide all three behind a single prompt box. Here's the mechanism. Each control the user selects gets silently folded into the underlying prompt. The interface is doing prompt engineering on the user's behalf. The user gets a cleaner experience, and the model gets sharper instructions. On the exam, if an answer describes the user specifying what they want, it's almost always right. If it promises filtered errors, no misinformation, or unique output every time, it's overclaiming and almost always wrong. Question 6. A writer is using generative AI to draft portions of a stage play and opens the prompt with the instruction, "You are an independent teenager living in a small coastal town." Which key prompt component is most clearly demonstrated in this scenario? Your options are A. Output format specification, B. Background context detail, C. Persona assignment for voice, D. Explicit task instructions. Which would you go with? Lock it in before the reveal. The correct answer is C. Persona assignment for voice. C is correct because telling the model it is an independent teenager assigns an identity and voice. This persona shapes word choice, attitude, and perspective throughout the generated dialogue the writer expects to receive. A is wrong because output format would describe the shape of the response, such as a sonnet, table, or bullet list. Saying the AI is a teenager does not indicate any format. B is wrong because context supplies background facts or situations that frame the query. The line assigns an identity rather than supplying setting information, backstory, or relevant external conditions to draw on. D is wrong because instructions state what the model should do, like write, summarize, or compare. Declaring who the AI is frames the speaker but does not issue an action to perform. Let's zoom out. Every well-formed prompt to a generative model can be broken into 4 moving parts, and knowing them is the foundation of every prompt component question on the exam. Persona names who the model is. Context names what it should know. Instruction names what it should do. Format names how the answer should look. 4 components, 4 fingerprints. Persona specifically assigns the model an identity. The moment a prompt uses identity language like "you are" or "act as," followed by a role, the component is persona. Those phrases are the fingerprints. Under the hood, a language model has absorbed millions of voices. Telling it to adopt a persona pushes its next words toward that region of training. A skeptical lawyer hedges. A teenager skips filler. The center of gravity in the generation changes. So on the exam, match the stem to the fingerprint. If it names a role the model should embody, the answer is persona, and the answer falls out. Question 7. A teacher wants an AI chatbot to write about a math topic for a creative classroom activity and includes the phrase "in the form of song lyrics" in the prompt sent to the tool. Which key prompt component is demonstrated in this scenario? Your options are A. Output format for the response, B. Persona for the AI speaker, C. Context about the math subject, D. Direct instructions about research. Don't overthink it. Which one feels right? The correct answer is A. Output format for the response. A is correct because requesting the answer as song lyrics specifies the shape and style of the output. Format components tell the model how to present information rather than what content to deliver. B is wrong because persona would assign the model a role, identity, or voice, such as a historian or a coach. Asking for song lyrics says nothing about who the speaker is. C is wrong because context gives background or relevant facts that frame the query. The lyrics phrase adds no classroom details, grade level, or specific math concepts the model should cover. D is wrong because instructions describe the action the model should take, like compare or summarize. Song lyrics specify presentation style, not the type of reasoning or research the model must perform. Let's talk about output format, the prompt component that controls how a response looks, not what it says. Think of format as packaging. The facts inside stay the same, but the container changes, whether that's a sonnet, a table, a bullet list, or a haiku. A teacher might ask for photosynthesis as a wrap for struggling readers, then as a comic script for visual learners. The facts are identical, only the container changes. That's why format earns its own slot. Format shows up in 3 flavors: length, like under 200 words, structure, like as a table or bullet points, and genre, like as a haiku or song lyrics. So on the exam, if the defining phrase names a shape, length, or genre, a container, the answer is output format. Persona names a speaker, context names the facts, instruction names the action. Format shapes how the answer looks. Question 8. A home cook wants to use an AI-based search tool to find recipe ideas for an evening meal and includes the phrase gluten-free somewhere in the prompt, so the suggestions will match a dietary need. Which term refers to this key component of a prompt? Your options are A. Output format for the recipe, B. Persona for the cook, C. Direct instructions for cooking, D. Context about dietary needs. Got a guess? Lock it in. The correct answer is D. Context about dietary needs. D is correct because noting gluten-free supplies relevant background that shapes the search space. Context components give the model conditions, facts, or constraints that guide it toward more appropriate and personalized results. A is wrong because output format specifies how the response should appear, such as a table, paragraph, or ranked list. Saying gluten-free does not describe the shape of the delivered answer. B is wrong because persona assigns the model an identity or voice, like a chef or nutritionist. Mentioning a dietary restriction adds information about the user, not a role for the model. C is wrong because instructions describe the action the model should perform, such as compare, rank, or explain. Gluten-free is a constraint on results rather than a verb telling the model to act. Let's dig into what context really means in a prompt, and why it's the element that shifts generic answers into specific ones. Think of context as walls. It's not the worker, not the task, not the output shape. It's the situational walls that narrow where the model can go before it even starts generating. 3 flavors show up on the exam. Situational context describes the user's circumstances. Constraint context names what must be true in the answer. Domain context names the field, like legal or medical. Every fact the user adds narrows the probability distribution the model uses. A prompt with no context returns the statistical average. Add gluten-free, 30 minutes, serves 4, and pantry staples, and the model reasons inside a much smaller room. If a phrase narrows a situation without giving the model a role, an action, or a format, it's context. Situation narrows the response space. That's the job context does. Question 9. A career counselor is helping a client draft a prompt for an AI assistant to explore a possible career change, and the prompt needs to include background knowledge and relevant facts that frame the situation. Which prompt component serves this exact purpose? Your options are A. Output format for the reply, B. Context for the question, C. Persona for the model, D. Input content samples. Which one is it? Pause the video if you need more time. The correct answer is B. Context for the question. B is correct because context is where a prompt includes background knowledge and relevant facts. That information contextualizes the user's query, so the AI can generate career suggestions that actually fit the situation. A is wrong because output format concerns the shape of the response, such as bullet points or a letter. Background knowledge about the client's career is substance, not a formatting choice for the reply. C is wrong because persona assigns the model an identity or voice, like a coach or interviewer. Background facts describe the client situation rather than who the AI is supposed to be. D is wrong because input content usually refers to raw material the model should process, like a pasted resume. Background framing information is lighter than a full document and functions as context. Let's talk about what context actually is in a prompt and why it matters so much for recommendations. Context is the background the model needs before it can answer usefully. Saying recommend a career gets a generic list. Saying 15 years as a nurse in Texas, burned out, wants something quieter gets a real conversation. Good career context usually includes 4 pieces: your current role, the skills you enjoy using, your constraints, and the direction you feel pulled toward. A skilled counselor elicits all 4. A good prompt supplies all 4. Career recommendations are multidimensional. A software engineer with 2 kids and back pain has a completely different answer space than one who wants to travel. Context tells the model to abandon the average and reason about this particular person. When a question mentions background knowledge, relevant facts, or situation framing, that's context. Watch out for input content, like a pasted resume, which is raw material to process. Context is lighter. It frames. Question 10. An instructional designer is teaching a lesson on prompt design and asks students to match example phrases to the correct prompt component. Which phrase clearly represents a persona rather than context or output format? Or direct task instructions for the model? Your options are A. Return the result as a table. B. Audience is first-year medical students. C. You are a patient ethics professor. D. Compare 3 approaches and recommend one. Take a second. Which answer would you pick? The correct answer is C. You are a patient ethics professor. C is correct because saying you are a patient ethics professor assigns the AI an identity and voice. That persona shapes how the model explains concepts, sets tone, and speaks to learners. A is wrong because asking for a table describes output format. Format instructions control the shape of the reply, specifying rows, columns, or structure rather than assigning a speaking role to the model. B is wrong because identifying the audience supplies context. Audience details help the model adjust depth and vocabulary, but context surrounds the task rather than transforming the model into a specific character. D is wrong because comparing 3 approaches and recommending one is a directive. Instructions tell the model what action to take, not who it is while performing the requested analytical work. Every prompt component leaves a different verbal fingerprint. Once you learn to read them, matching questions become mechanical. Persona uses identity language. Context uses situational language. Output format uses shape language. Instruction uses action language. Each component leaves its own signature, and each one fails differently when missing. Persona always assigns a role, profession, or character to the model itself. You are a patient ethics professor. Act as a detective. The giveaway is that the phrase tells the model who it is pretending to be. Under the hood, a persona shifts the statistical center of gravity in the model's word generation. The knowledge pool stays the same, but the voice drawing from it changes sharply, depending on who you tell the model to be. When a matching question asks for persona, find the option that assigns a role or identity. 4 fingerprints, 1 answer each. Read the language and the answer surfaces. Question 11. A vacation rental host wants to use a large language model to help draft a compelling property description for a new listing and has been reading tips on writing stronger prompts. Which benefit most directly comes from writing an effective, specific prompt in this context? Your options are A. Proven and perfect response. B. Reduced need for clarifying exchanges. C. Description customized for each reader. D. Improved interface for the user. Before I reveal it, which one do you think is right? The correct answer is B. Reduced need for clarifying exchanges. B is correct because a specific prompt tells the model exactly what is needed up front. The host avoids a long back and forth, saves time, and gets a draft that is closer to usable. A is wrong because no prompt guarantees a proven and perfect response. Generative models still produce errors, and even well-crafted prompts often require review, small edits, or follow-up for final quality. C is wrong because a single generated description does not automatically adapt to every reader. Effective prompts improve clarity and fit, but personalization for individual browsers requires extra tooling or repeated prompting. D is wrong because prompt quality does not modify the underlying interface. The tool's layout, buttons, and controls stay the same regardless of how carefully the host writes the input prompt text. Let's talk about why specificity in prompts matters so much and what it really saves you. A specific prompt is the interface's version of measuring twice and cutting once. A vague prompt triggers a negotiation, generic answer, follow-up, adjustment, repeat. A specific prompt skips most of that loop by telling the model exactly what you want up front. 3 kinds of detail reliably reduce clarifying rounds. Audience names who it's for. Constraints name what must appear. Tone names the feel. Nail all 3 and you usually get usable output on the first try. Here's the mechanism. Each detail you add reduces the model's uncertainty, which means fewer guesses and less random output. The vague path burns time through round after round of clarification. The specific path lands close on the first attempt. On the exam, the right answer about specific prompts is almost always about efficiency and fewer follow-ups. Not perfection, not personalization, not a better interface. Just time saved, which is exactly what working professionals care about most. Question 12. A couple is using an AI-based search tool to help decide where to take an upcoming vacation within the United States and wants the results to reflect what they actually care about. Why is writing an effective prompt important in this kind of situation? Your options are A. The prompt secures all reservations. B. The prompt must indicate the location. C. The prompt expresses the user intent. D. The prompt guarantees enjoyable travel. What's your answer? Commit to one before I continue. The correct answer is C. The prompt expresses the user intent. C is correct because the prompt is the couple's main way of communicating what matters, such as budget, activities, and climate. Clearly expressed intent leads the model toward destinations that truly fit their needs. A is wrong because search tools surface information rather than complete bookings. Actually reserving flights, lodging, or activities still happens through travel sites. So prompts cannot directly secure those reservations for the couple. B is wrong because the couple wants suggestions, not a predetermined location. If the prompt already named the destination, the model would only confirm a choice instead of helping compare real options. D is wrong because no prompt can guarantee an enjoyable trip. Enjoyment depends on weather, travel partners, and unexpected events that lie outside what any AI search tool can reliably predict. So why does the wording of a search prompt matter so much? Let's look at the underlying principle. A prompt is an expression of user intent. Think of the AI as a matchmaker and the prompt as your only mouthpiece. Say best vacation spots and you get the internet's average opinion. Say what actually matters and you get something useful. 3 kinds of intent usually matter. Priorities, what must be true. Constraints like budget and distance. Preferences, the things that make a trip feel right. Cover all 3 and the model can actually match. Mechanically, the prompt is the only channel into the user's head. Everything else is inference or training defaults. If the couple wants quiet, the prompt has to say quiet because no other channel exists. The prompt doesn't reserve, guarantee, or name the destination. It expresses what the user wants. That expression is how intent crosses the screen and reaches the model. Question 13. A new hobbyist wants to use an AI-based search tool to learn about homesteading topics, including raised beds, chickens, and water collection, but the hobbyist is unsure how to craft a strong initial query for the model. What is the main risk of writing a poor prompt? Your options are A. Much greater device data usage. B. Only opinion-based information returned. C. Fully outdated results every time. D. Imprecise and unhelpful results. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is D. Imprecise and unhelpful results. D is correct because vague prompts force the model to guess, so answers tend to be broad, generic, or off-topic. The hobbyist ends up reworking the query instead of getting a useful first response. A is wrong because data usage depends on the platform and volume of responses, not specifically on prompt quality. A weak prompt may waste effort, but it does not noticeably increase data consumption in practice. B is wrong because a poor prompt does not automatically skew toward opinions. It usually produces a shallow mix of general information, which may still include facts along with some subjective commentary. C is wrong because currency of results depends on the model's training data and any connected search, not on prompt style. Bad prompts produce imprecise responses rather than uniformly outdated historical content. Let's talk about why weak prompts are dangerous. The real risk isn't a wrong answer, it's a fuzzy one that sounds helpful but isn't. When your prompt is specific, the model narrows its response toward what you actually need. When it's vague, the model defaults to the statistical center of its training data, broad, generic, and shallow. Weak prompts usually fail in 3 ways. Topic drift, where the answer wanders. Depth mismatch, too basic or too technical. And missed constraints, where your actual situation gets ignored entirely. Here's the pattern in practice. A beginner asking generically about chickens gets a list of breeds. A beginner adding specifics, household size, climate zone, lot type, goals, gets actual guidance. Same tool, completely different result. On the exam, the trap answers overclaim. Data usage, opinions, outdated info. The honest answer is almost always imprecision. Vague in, vague out. Question 14. A marketing analyst is comparing the outputs produced by short, vague prompts and more detailed, carefully worded prompts while writing a training guide for colleagues who are new to generative AI tools. Which advantage most directly results from detailed prompt descriptions? Your options are A. Facilitation of more accurate responses. B. Wider random response generation. C. Greater generative creativity overall. D. Lower use of local computing. Which would you go with? Lock it in before the reveal. The correct answer is A. Facilitation of more accurate responses. A is correct because detailed descriptions reduce ambiguity and guide the model toward the specific topic, audience, and purpose the analyst wants. Clearer signals produce answers that align more closely with actual intent. B is wrong because detail narrows the response rather than widening it. Randomness tends to grow when prompts are vague, since the model has more freedom to guess what the user might want. C is wrong because creativity is not the main reason to add detail. Strong prompts trade some openness for precision. So teams use them when they want reliability rather than wide-open creative exploration of ideas. D is wrong because prompt length does not significantly change local hardware demand. Processing happens on the provider's servers, and users feel little difference in their own machine's computing footprint per request. Let's look at why detail is the single most reliable lever for getting accurate answers from a generative AI. The reason is almost mathematical. A vague prompt leaves many words roughly equally likely, so the model picks something in the middle. A detailed prompt sharpens those probabilities, shifting mass toward the answer you actually wanted. 3 kinds of detail carry the most weight. Audience, who the output is for. Scope, what to include and leave out. Purpose, why the user needs it. A prompt with all 3 producers answers accurate enough for working use. The trade-off worth naming. Detail reduces creativity. A vague prompt leaves room to surprise. A detailed prompt constrains the model toward a specific kind of answer. For marketing work, reliability usually wins. So on the exam, if an answer names accuracy, alignment, or reliability as the benefit of detail, that is almost always correct. If it names wider output or creativity, that's the distractor. Question 15. During senior year of high school, a student types the very short prompt recommendations for college into an AI assistant and gets a list of broadly famous schools that do not match any personal interest or situation. How should the student improve the prompt? Your options are: A. Use grammatically correct question form. B. Begin the prompt with please. C. Add personal contact information. D. Include the motivation for asking. Don't overthink it. Which one feels right? The correct answer is D. Include the motivation for asking. D is correct because the model does not know what the student actually cares about. Adding goals, intended major, location preferences, or budget tells the assistant which schools would genuinely suit this particular student. Is wrong because grammatical form has a minor effect on response quality. Models handle fragments and full questions fairly well, so rewriting in question form would barely change the quality of the recommendations. B is wrong because politeness words like please do not add information. The model still has no data about the student's goals, so the response would remain generic despite the friendlier phrasing of the query. C is wrong because sharing contact information is a privacy risk and adds no context about school preferences. The assistant does not need identifiers to make a well-targeted college recommendation list for the student. Let's talk about why most weak prompts are weak. It's almost never about grammar or politeness. It's about something much deeper. Think of it this way. A prompt without motivation is like a shopping list without a shopper. The model has no idea who it's buying for, so it grabs whatever is most famous on the shelf. Mechanically, motivation works as a selector. The model's training data contains schools for artists, engineers, budget-conscious students, warm weather lovers. Without motivation, it defaults to the famous slice because fame dominates its training data. 3 kinds of motivation help most. Academic goals like your major or career path. Life goals like climate or proximity to family. And financial goals like scholarships or debt tolerance. Include all 3 and the response transforms. So on the exam, when you see distractors about grammar or politeness, skip them. The real fix is almost always adding the user's reason, goals, or constraints. Motivation is the silent missing ingredient. Question 16. A researcher is writing a quick explainer of prompt engineering methods for a webinar and needs to describe the approach that expects a generalized response from a language model because no relevant training examples are included in the prompt itself. Which method is this? Your options are A. Zero-shot prompting. B. Few-shot prompting. C. Generated knowledge. D. Cognitive verifier pattern. Got a guess? Lock it in. The correct answer is A. Zero-shot prompting. A is correct because zero-shot prompting asks the model to handle a task without any example inputs or outputs. It relies entirely on pre-training knowledge, which produces general but sometimes less precise answers overall. B is wrong because few-shot prompting deliberately provides a small number of example pairs inside the prompt. Those examples guide the model's style and expected answer shape, which is the opposite setup described here. C is wrong because generated knowledge prompting asks the model to produce relevant facts first and then use them to answer. It adds content to the prompt rather than leaving examples completely absent from it. D is wrong because the cognitive verifier pattern has the model ask clarifying questions before answering. It is an interactive method rather than a description of whether examples appear in the prompt at all. Let's zoom out and talk about zero-shot prompting. The baseline that all the other name techniques are defined against. Zero-shot means you hand the model a task with no demonstrations attached. It leans entirely on knowledge absorbed during training, which is why it handles common tasks well but often gets vague on unusual or highly structured ones. The easiest way to lock it in is by contrast. Few-shot adds example pairs. Chain of thought adds step-by-step reasoning. Generated knowledge adds a facts-first stage. Zero-shot adds none of these. It's the plain prompt the other three build on top of. On the exam, watch for these exact phrases. No examples, no demonstrations, relies on pre-training, general response. Those are all fingerprints of zero-shot. If examples appear in the scenario, it's few-shot instead. Zero-shot is the default. Just the question, nothing else. Recognize that pattern and every other name technique slots neatly into place around it. Question 17. A content moderator is preparing a prompt that will label customer messages as positive, negative, or neutral, and wants to enhance the model's performance by providing a handful of carefully labeled examples before the new message. Which method of prompt engineering is this? Your options are A. Zero-shot prompting, B. Few-shot prompting, C. Least to most prompting, D. Self-consistency prompting. Which one is it? Pause the video if you need more time. The correct answer is B. Few-shot prompting. B is correct because few-shot prompting supplies a small set of worked examples inside the prompt. Those demonstrations let the model pick up patterns quickly, which improves performance on similar, previously unseen cases during labeling. A is wrong because zero-shot prompting includes no examples at all. The moderator is deliberately showing labeled messages, which is more than nothing and fits the few-shot definition far better than zero-shot. C is wrong because least to most prompting gradually increases complexity across prompts, rather than offering examples at once. It is about scaffolding difficulty, not demonstrating the expected labeling format and tone for the model. D is wrong because self-consistency prompting runs the same prompt multiple times and picks the most common result. It focuses on answer stability, not on teaching the model through supplied example pairs beforehand. Let's unpack the theory behind few-shot prompting and why it became the default technique for production language model work. Few-shot means dropping 2 to 10 worked examples directly into the prompt before the real task. The model sees how inputs map to outputs and imitates that pattern on the new input, closing most of the gap between zero-shot and full fine-tuning. Mechanically, language models are excellent at pattern completion. They treat the prompt as a document with a clear structure and generate what comes next. If 3 messages are labeled positive, negative, positive, the model extends that same pattern onto the new input. The key ingredient is consistency across examples. Every example should use the same format, the same kind of reasoning, and produce the same type of output. Break consistency and the pattern breaks with it. On the exam, look for phrases like example pairs, labeled examples, or demonstrations inside a single prompt. Zero shot has none. Chain of thought asks for reasoning steps. Only few shot shows examples up front. That is the identifier every time. Question 18. A tutor is walking a student through solving a multi-step word problem and deliberately sends a series of prompts to the AI, with each successive prompt adding more complexity to the reasoning expected of the model. Which advanced prompting technique does this describe? Your options are A. Zero-shot prompting, B. Generated knowledge prompt, C. Least to most prompting, D. Few-shot prompting. Take a second. Which answer would you pick? The correct answer is C. Least to most prompting. C is correct because least to most prompting breaks a problem into subtasks that grow in difficulty. Each prompt builds on prior answers, letting the model and the learner progress toward the full solution step by step. Is wrong because zero-shot prompting provides no examples and no scaffolding. The tutor is deliberately building complexity across prompts, so the interaction is richer than a single attempt without prior support given. B is wrong because generated knowledge prompting first asks the model to produce helpful facts, then reuses them. That is a single enrichment step rather than a staircase of rising complexity prompts delivered over time. D is wrong because few-shot prompting adds labeled examples within a single prompt. The tutor is instead issuing a sequence of prompts that grow harder, which is a distinct pedagogical technique from few-shot work. Least to most prompting is really a staircase technique. Let's look at why it works and where the idea comes from. The idea predates generative AI. Vygotsky's zone of proximal development from the 1930s argues learners progress fastest when each step is just beyond their current reach. Least to most applies that same scaffolding to language models. 3 elements define a least to most sequence. Decomposition splits the problem into subtasks. Ordering arranges them from easiest to hardest. Chaining feeds each answer into the next prompt. Get these wrong and it collapses into ordinary multi-turn chat. Mechanically, models that fail on a problem in one shot often succeed when it's split across steps. Each prompt carries less reasoning load, so fewer mistakes accumulate. Khan Academy's Khan Migo uses exactly this pattern, asking easier questions that build toward the full solution. On the exam, watch for a sequence of prompts across time, each harder than the last. Few-shot is examples in one prompt. Chain of thought is one prompt. Least to most is the staircase. Question 19. A high school teacher writes an AI prompt asking the assistant to find the shortest path on a city map and includes the phrase, "Explain the process step by step," so students can follow the reasoning clearly. Which prompting technique is most clearly demonstrated? Your options are A. Chain of thought prompting, B. Generated knowledge prompt, C. Few-shot prompting, D. Self-consistency prompting. Before I reveal it, which one do you think is right? The correct answer is A. Chain of thought prompting. A is correct because asking for a step-by-step explanation is the hallmark of chain of thought prompting. The technique encourages the model to show intermediate reasoning, which often improves accuracy on multi-step problems like this one. B is wrong because generated knowledge prompting first asks the model to produce background facts before the main task. Requesting step-by-step reasoning emphasizes working through the problem rather than pre-generating outside knowledge that gets reused later. C is wrong because few-shot prompting depends on supplying worked example pairs in the prompt. The teacher does not provide sample routes with solutions, so the prompt is not using few-shot cues for guidance. D is wrong because self-consistency prompting repeats a prompt several times and selects the most common answer. A single prompt asking for step-by-step work is not an aggregation across multiple model runs performed separately. Let's look at why chain of thought prompting works so well. It's not magic. It mirrors something teachers have known for decades. Math teachers have long noticed that students who write out their work get more right answers than students who calculate silently. Showing the steps forces the brain to check each piece rather than jumping to a gut answer. Language models exhibit exactly the same pattern. Mechanically, models generate one word at a time, each conditioned on the previous words. Without reasoning, the model has almost no context before committing. With reasoning first, it builds a runway of supporting thought. The reasoning acts as scratch paper. There are 3 ways to trigger chain of thought in practice. Direct instruction asks explicitly for steps. Demonstration shows an example solved step by step. Question design uses why or how to invite reasoning. Direct instruction is the most common because it takes the least effort. Step by step is the tell. Whenever a prompt asks the model to explain its reasoning or walk through the process, that's chain of thought. Every time. The technique turns the model from a guesser into a reasoner. Question 20. A novelist is using an AI tool to continue a mystery story and wants plot and character details to stay aligned across regenerations. To achieve this, the novelist runs the same prompt multiple times and picks the most stable version. Which technique is this? Your options are A. Chain of thought prompting, B. Zero-shot prompting, C. Few-shot prompting, D. Self-consistency prompting. What's your answer? Commit to one before I continue. The correct answer is D. Self-consistency prompting. D is correct because self-consistency prompting generates multiple candidate outputs for the same prompt and favors the most common or stable one. This supports narrative alignment when consistency matters more than wild variety in responses. A is wrong because chain of thought prompting asks the model to show reasoning steps for a single answer. Running a prompt repeatedly for stability is a different workflow focused on aggregating results across runs. B is wrong because zero-shot prompting names whether examples appear, not whether the prompt is run repeatedly. The novelist could run a zero-shot prompt many times, but the repetition is the distinguishing feature here. C is wrong because few-shot prompting inserts labeled examples inside the prompt. The novelist is not showing sample story continuations, but instead choosing among multiple full generations of the same prompt over time. Self-consistency is the statistics approach to generative AI. Run the same prompt many times, then pick the winner. 3 ingredients make it work. Multiple runs of the same prompt, usually 5 to 20. Some randomness from a non-zero temperature, so the runs actually differ. And a selection rule, typically majority vote, to crown a winner. The intuition is older than AI. In 1906, Francis Galton found that averaging 800 fairgoers' guesses about an ox's weight landed remarkably close to the truth. Aggregating independent attempts cancels noise and stabilizes on the signal. Because language models are probabilistic, each run samples slightly different words and sometimes different answers. On hard questions, single runs are noisy. Across many runs, the noise cancels and the most frequent answer emerges as the model's most confident one. On the exam, the fingerprint is repetition across runs plus selection across outputs. When the scenario describes running a prompt many times and picking the most stable result, that is self-consistency by name. Question 21. A market analyst asks an AI model to forecast near-term market trends and keeps steering the model toward the indicators that already match the analyst's favored thesis, even as other signals suggest a weaker outlook. Which form of bias is most clearly present? Your options are A. Sampling bias, B. Selection bias, C. Confirmation bias, D. Algorithmic bias. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is C. Confirmation bias. C is correct because confirmation bias occurs when people favor information that supports existing beliefs. The analyst privileges agreeable signals and underweights contradictory ones, which skews the forecast toward the preferred conclusion rather than reality. I is wrong because sampling bias arises when training data disproportionately represents certain groups or situations. The analyst's behavior is about interpretation during use, not about the composition of the underlying dataset used for training. B is wrong because selection bias stems from non-random choices during data collection. The issue here is the analyst's interpretation of the model's output, not how the training sample was originally chosen or assembled. D is wrong because algorithmic bias comes from how a model is designed or implemented. The slant in this case is introduced by the user steering inputs, not by the algorithm's internal structure or logic. Let's talk about confirmation bias, the oldest error in human reasoning, now supercharged by AI. Psychologist Peter Wason named it in the 1960s. Subjects guessed a number rule and almost all sought only confirmations of their first guess, missing the real pattern entirely. The same error has been replicated across medicine, law, and finance, and it follows us into AI-assisted work. 4 biases get confused on this exam, but one axis separates them cleanly. Sampling, selection, and algorithmic bias all happen before or inside the model. Confirmation bias happens after, in how the human reads the output. The mechanism is subtle. An analyst prompts in ways that implicitly request support. The model obligingly complies, and the thesis comes back looking confirmed. No dishonesty, just a feedback loop between a biased human and a fluent machine. On the exam, watch for words like favored, already believed, or steered toward. That's confirmation bias every time, the human refusing to be surprised by the tool. Question 22. An employer trains an AI model to predict employee turnover using records drawn only from long-tenured staff. The employer then notices the model makes poor predictions for workers who joined recently. Which form of bias most clearly explains this outcome on the job? Your options are A. Confirmation bias, B. Selection bias, C. Measurement bias, D. Algorithmic bias. Which would you go with? Lock it in before the reveal. The correct answer is B. Selection bias. B is correct because selection bias occurs when training data is chosen non-randomly. The employer drew only from long-tenured staff, so the model cannot generalize to shorter tenure employees whose patterns are missing from training. A is wrong because confirmation bias is about favoring evidence that matches existing beliefs. The employer's problem is an imbalanced training sample, not a pattern of interpretation during the forecasting or review process itself. C is wrong because measurement bias comes from errors in how data is collected or recorded, such as faulty sensors. The employer's data may be accurate but was drawn from the wrong group of employees. D is wrong because algorithmic bias stems from model design choices or implementation details. The issue described lies in the data that was chosen to train the model, not in the algorithm itself. Selection bias is one of the most common and costly flaws in machine learning projects. Let's understand why who gets into your training data matters just as much as what you measure. The classic cautionary tale is the 1936 Literary Digest poll, which sampled telephone and car owners during the Depression. It confidently predicted Alf Landon would beat Franklin Roosevelt. Roosevelt won in a landslide, and the magazine folded soon after. Machine learning inherits the same vulnerability whenever training records are chosen non-randomly. 4 flavors are worth memorizing. Survival bias keeps only successful cases. Availability bias includes only easy-to-collect records. Opt-in bias captures only those who chose to participate. And survivor company bias includes only firms still in business. All 4 produce the same structural flaw. Amazon learned this the hard way. The automated hiring model was trained on past successful hires, who were disproportionately men. The model dutifully learned to prefer men, and Amazon killed the project in 2018. The algorithm wasn't broken. The sample was. On the exam, look for the fingerprint, a non-random filter during data collection. Long tenured only, successful cases only, volunteers only. The model cannot see what was never shown to it. Missing voices become missing predictions. Question 23. A startup builds a facial recognition tool using a training dataset that contains mostly images of light-skinned individuals. Once deployed, the tool performs noticeably worse on other skin tones. Which type of bias in AI training data does this scenario illustrate clearly? Your options are A. Algorithmic bias, B. Confirmation bias, C. Measurement bias, D. Sampling bias. Don't overthink it. Which one feels right? The correct answer is D. Sampling bias. D is correct because sampling bias happens when training data disproportionately represents certain groups. Light-skinned faces dominated the dataset, so the tool learned their features well while underperforming on underrepresented populations once it was deployed. A is wrong because algorithmic bias arises from how the model is designed or implemented. The issue here is the content of the training set, not a flaw baked into the architecture or ranking logic. B is wrong because confirmation bias is a human cognitive pattern of favoring agreeable evidence. The startup's problem is the composition of images used for training, not how anyone interprets the model outputs later. C is wrong because measurement bias comes from errors in how data is captured or recorded, such as miscalibrated cameras. The images themselves may be accurate. The group imbalance is the real underlying issue. Let's talk about why biased AI usually isn't a broken algorithm. It's a broken data set. Sampling bias happens when training data doesn't proportionally represent the real population. The model overlearns the majority group and underlearns the minority. Exactly what the math predicts, with no bad intent required. The landmark example is Joy Buolamwini's gender shade study. She tested commercial systems and found error rates up to 34 points higher on darker-skinned women than on lighter-skinned men. The systems weren't malicious. They were sampling biased by data. On the exam, keep 3 ideas distinct. Sampling bias is about proportions in the training data. Selection bias is about how records were chosen. Measurement bias is about errors in the recording itself. If the scenario describes imbalanced training data across demographics, that's sampling bias by name. The fix is better proportions and not cleverer algorithms. Question 24. A technology firm deploys an AI recruitment tool that consistently favors applicants who resemble previous hires, even when equally qualified candidates from other backgrounds apply. Reviewers trace the behavior to choices made while designing the ranking algorithm. Which type of bias is this? Your options are A. Algorithmic bias, B. Measurement bias, C. Sampling bias, D. Confirmation bias. Got a guess? Lock it in. The correct answer is A. Algorithmic bias. It is correct because algorithmic bias is introduced by choices in how a model is designed or implemented. A ranking system that rewards similarity to past hires is an algorithmic design decision, not merely a data issue. B is wrong because measurement bias comes from errors in how data is collected, such as faulty instruments or inconsistent coding. The flaw described here lives in the algorithm itself, not in data capture. C is wrong because sampling bias is about non-representative training data. The investigators trace the issue to deliberate ranking logic rather than to imbalance in who appeared within the training examples for the model. D is wrong because confirmation bias describes human interpretation favoring familiar conclusions. Although the outcome resembles human favoritism, The mechanism here is baked into the algorithm itself, which makes it algorithmic bias. Let's go deeper on algorithmic bias, the kind of unfairness that lives not in the data, but in the code itself. Think of an algorithm as an opinion embedded in math. When a recruitment tool ranks applicants by similarity to past hires, it has been told that resemblance equals quality. The data may be perfectly clean, but that single design choice quietly defines what good looks like. In production systems, algorithmic bias usually enters through 4 design choices, which features get selected, what objective the model optimizes, how similarity is measured, and where decision thresholds are set. Each one is a human decision baked into the code. The landmark example is Compass, a courtroom risk tool exposed by ProPublica in 2016 for assigning higher risk scores to black defendants with similar profiles to white ones. The disparity came partly from how the algorithm weighted features, making it the clearest published case of algorithmic bias in government use. So the fingerprint to watch for: ranking logic, weighting, model design, implementation choices. Sampling bias lives in the data. Algorithmic bias lives in the code, and changing the data won't fix it. Question 25. A responsible AI working group is preparing a short list of practices that teams should adopt at the start of a new machine learning project to reduce the risk of biased outcomes later. Which strategy most directly helps address data bias in AI? Your options are A. Training only on synthetic data, B. Avoiding all real-time updates, C. Collecting diverse and representative data, D. Limiting the overall model size. Which one is it? Pause the video if you need more time. The correct answer is C. Collecting diverse and representative data. C is correct because diverse and representative training data captures the range of people, situations, and conditions the model will face in use. Balanced coverage directly reduces the most common forms of data bias. A is wrong because synthetic data alone does not guarantee fairness. If the generator was trained on skewed inputs, synthetic samples can inherit or even amplify the same biases that real data already carries. B is wrong because avoiding real-time updates has little to do with bias. Models still need current data to reflect reality, and refusing updates would hurt accuracy rather than reduce unfair outcomes for affected groups. D is wrong because model size is not the root cause of biased behavior. Smaller models can remain biased if their training data is skewed, so shrinking architecture does not solve fairness issues on its own. Before we talk about algorithms, let's talk about the single highest leverage move in any machine learning project: collecting data that actually represents who the model will serve. This isn't philosophy, it's statistics. Whatever data you feed a model becomes its default assumption about reality. A narrow slice in means a narrow slice out, and no clever architecture can fix that blindness later. 3 practical moves define it. Demographic balance, so the groups the model serves are proportionally present. Contextual coverage, spanning lighting, devices, and regions. And temporal range, because a model trained only on January data won't perform in July. The American framework for this comes from NIST's AI Risk Management Framework, released in 2023. It names representative data collection as foundational, and major firms like IBM, Salesforce, and most banks have aligned with it. Everything downstream sits on this layer. So when a question asks what to do at the start of a project to reduce bias, the answer is almost always representative data collection. Foundations before features. Data before architecture. Question 26. A development team is drafting an ethics checklist for a new AI product and wants to clearly name the principle that is most directly promoted when the team deliberately works to mitigate biases in algorithms, so that outcomes do not discriminate against groups. Your options are A. Privacy, B. Accountability, C. Transparency. D. Fairness. Take a second. Which answer would you pick? The correct answer is D. Fairness. D is correct because fairness is the ethical dimension centered on preventing discriminatory outcomes. Actively mitigating bias in algorithms and decisions is how teams operationalize fairness and protect users from unequal treatment. A is wrong because privacy focuses on safeguarding sensitive personal information and controlling how data is collected, stored, and shared. It is distinct from the work of addressing discriminatory algorithmic outcomes directly. B is wrong because accountability concerns who bears responsibility when AI causes harm and how recourse is provided. It is a related but separate principle from preventing discriminatory outcomes through bias mitigation. C is wrong because transparency is about making AI decisions understandable and explainable to users and regulators. It helps people examine models but does not itself remove bias from algorithmic decisions. Let's go deeper on fairness as a principle in AI ethics, and why bias mitigation is the operational lever that brings it to life. Fairness isn't about identical results for everyone. It's about ensuring the algorithm doesn't systematically harm protected groups in ways that violate anti-discrimination law or basic ethics. When teams mitigate bias, they're operationalizing this principle directly. 4 fairness concepts dominate practice: demographic parity, equal opportunity, individual fairness, and counterfactual fairness. They're all legitimate, and they sometimes conflict. So teams must choose which version of fairness they're optimizing for. Fairness in AI inherits 6 decades of American civil rights law. A lending algorithm with disparate impact by race faces the same scrutiny as a human loan officer. Recent rules like NYC's Local Law 144 now require annual bias audits of hiring AI. On the exam, if the scenario describes discriminatory outcomes across groups or bias mitigation work, the principle is fairness. Privacy guards information. Accountability assigns responsibility. Transparency explains decisions. Only fairness targets equal treatment. Question 27. An engineering review board is evaluating a fleet of AI-based self-driving vehicles and must name the ethical consideration that most directly includes identifying and mitigating the risks of physical harm to passengers, pedestrians, and other drivers. Which consideration is this? Your options are A. Safety, B. Accountability, C. Transparency, D. Fairness. Before I reveal it, which one do you think is right? The correct answer is A. Safety. A is correct because safety as an AI ethics principle focuses on identifying and mitigating risks of physical and psychological harm. Self-driving systems must minimize crash risks for passengers and those nearby. B is wrong because accountability is about assigning responsibility and providing recourse when AI causes harm. It applies after incidents occur, while safety aims to prevent physical harm from happening in the first place. C is wrong because transparency concerns making AI decisions understandable and traceable. Clear documentation helps audits, but it does not itself address the physical risks that self-driving vehicles pose to humans nearby. D is wrong because fairness focuses on preventing discriminatory outcomes across demographic groups. Equity matters for self-driving vehicle policy, but the direct protection against physical harm falls under the ethics principle of safety. Let's zoom out and talk about why safety holds a special place among AI ethics principles, especially for self-driving vehicles. Every ethics principle matters, but only safety is directly about keeping bodies from being hurt. Fairness fights discrimination, transparency enables explanation, accountability assigns responsibility. Safety is the one where failure can kill someone. Modern safety engineering breaks the problem into 4 dimensions. Physical safety protects humans from the system's actions. Cybersecurity defends against attackers. Reliability guards against internal failures. And robustness handles situations the model was never trained on. Safety and self-driving works through layered defense. Redundant sensors cross-check each other. The car signals its intent. It degrades gracefully when uncertain. And human operators watch over edge cases. Each layer catches what the others miss. So on the exam, the fingerprint is simple. If the scenario involves physical risk to bodies, passengers, pedestrians, crash risk, injury, the principle is safety. Lives on the line means safety by name. Question 28. An employer enters sensitive employee data into an external AI model so the system can analyze trends in workplace satisfaction, and the AI model stores and uses that personal data for training. Which ethical concern is most directly described in this scenario? Your options are A. Autonomy, B. Accountability, C. Privacy, D. Transparency. What's your answer? Commit to one before I continue. The correct answer is C. Privacy. C is correct because privacy covers how sensitive personal information is collected, stored, and used. Feeding employee records into a model that retains them for further training raises clear concerns about consent and data handling. A is wrong because autonomy in AI ethics usually concerns how much independent control a system has over real-world actions. The employee data situation is about information handling rather than an autonomous system acting. B is wrong because accountability names who is responsible when AI causes harm and how users can seek recourse. The primary issue here is personal data exposure, which belongs to the privacy dimension entirely. D is wrong because transparency concerns whether AI decisions can be explained and examined. The scenario emphasizes what happens to personal employee information, which fits privacy rather than explainability of model behavior. Let's talk about privacy as an AI ethics principle, and why it's the one that applies whenever personal data enters a system that wasn't built to guard it. 3 patterns show up again and again. Unauthorized collection happens without informed consent. Purpose creep repurposes data beyond its original use. Third-party exposure sends data into a vendor's systems without adequate controls. In 2023, Samsung engineers pasted proprietary code into ChatGPT to debug it. That code then lived on OpenAI's servers under terms that allowed training. Samsung banned external chatbots within weeks, and every major American firm followed. On the exam, the fingerprint is clear. Autonomy is about system control. Accountability is about responsibility. Transparency is about explainability. Only privacy directly concerns what happens to personal data. If the scenario names sensitive information being fed to a model, exposed to a vendor, or retained for training, privacy is the issue. Data protection is the frame, and control is the goal. Question 29. An AI-based drone is used to spray insecticides on agricultural land and recently malfunctioned, releasing chemicals over a nearby residential area. The owner struggled for many minutes to disable the drone. Which ethical issue is most relevant to this scenario and that delay? Your options are A. Misinformation, B. Autonomy, C. Privacy, D. Transparency. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is B. Autonomy. B is correct because autonomy in AI ethics concerns how much independent control a system exerts and how quickly humans can override it. A drone that resists disabling highlights gaps in human oversight. A is wrong because misinformation involves AI generating or spreading false content. A drone physically releasing chemicals over the wrong area is an operational control problem rather than a factual accuracy issue about information. C is wrong, because privacy concerns how personal data is handled. While residents might feel intruded upon, the central ethics problem described is the lack of timely human control over an autonomous system acting. D is wrong because transparency concerns whether AI decisions can be examined and understood afterward. The immediate concern here is the operator's inability to stop the drone quickly, which is an autonomy problem. Let's talk about autonomy in AI ethics. It's the question of who's really in control when a machine acts in the real world. Autonomy has three dimensions that matter: how much the system does on its own, how easily a human can intervene, and how clearly the human can see what the system is doing and why. When all three gaps appear together, you have an autonomy crisis. The Boeing 737 MAX crashes in 2018 and 2019 became a watershed moment. An automated system called MCAS kept pushing the plane's nose down while pilots struggled to override it. 246 people died, and the aviation industry was forced to rethink how autonomous systems should defer to human control. This is what aviation calls automation complacency. When a human has been watching the system run for an hour, they aren't warmed up for the 3 seconds when something goes wrong. The more autonomous the system, the more carefully the handoff back to a human must be engineered. So on the exam, the fingerprint of autonomy is independent action combined with delayed or failed human override. Human oversight is the target and override is the mechanism. Question 30. A policy advisor is explaining a principle of AI ethics that includes considerations of how AI technologies influence widespread access to resources and opportunities, including the risk of amplifying existing inequalities in employment and services. Which principle is being described? Your options are A. Societal impact, B. Transparency, C. Accountability, D. Fairness. Which would you go with? Lock it in before the reveal. The correct answer is A. Societal impact. A is correct because societal impact captures how AI shapes access to resources, opportunity, and broader public life. It includes effects on employment, services, and the distribution of benefits across diverse communities over time. B is wrong because transparency concerns whether AI decisions can be examined and understood. Explainability supports good policy, but the broad effects on access and opportunity fall under a different ethical lens entirely. C is wrong because accountability is about who is responsible for AI outcomes and how harm is remedied. It deals with recourse rather than shaping access to widespread social resources and opportunity. D is wrong because fairness focuses on preventing discriminatory outcomes in individual AI decisions. Although related, the principle describing broad effects on access and opportunity is societal impact rather than fairness alone. Let's zoom out from the question and look at the bigger principle, societal impact in AI ethics. Fairness asks whether one specific decision was equitable. Societal impact asks what happens when millions of those decisions accumulate across communities, industries, and labor markets. AI shapes society through 3 main channels: jobs automated or created, services concentrated in wealthy regions, and AI-generated content reshaping what populations see and believe. Even if every individual decision is perfectly fair, the cumulative pattern across millions of deployments can still widen inequality. That aggregate view is what societal impact captures. When a scenario mentions widespread access, amplified inequalities, or broad effects on employment and services, the principle being named is societal impact. Question 31. A student using an AI assistant to help with a research paper notices that one of the articles cited by the model does not actually exist when the student checks a library database. Which AI phenomenon is most clearly described by the situation and citation? Your options are A. Data drift, B. Adversarial attack, C. Sampling noise, D. AI hallucination. Don't overthink it. Which one feels right? The correct answer is D. AI hallucination. D is correct because an AI hallucination is a plausible sounding but false or fabricated output. Generating a fake citation that looks real but does not exist is a textbook example of the phenomenon. A is wrong because data drift describes performance decline as the real-world distribution changes over time. Inventing a citation is a generation error, not a mismatch between the training distribution and current data. B is wrong because an adversarial attack involves deliberately crafted inputs designed to fool the model. The student is simply making a standard research request, not attempting to manipulate the assistant through malicious inputs. C is wrong because sampling noise describes small, random variations within statistical estimates. A fully invented article is a confident fabrication rather than a small stochastic fluctuation in the model's output for the query. Let's dig into what an AI hallucination actually is and why it happens. A hallucination is output that sounds confident and correct but is actually fabricated. The model isn't lying. It's generating text that sounds the way correct text sounds without verifying whether the facts exist. Here's the mechanism. Language models are trained to produce plausible continuations of text. Plausibility is not the same as truth. A fake citation follows every convention of a real one, so the model generates it happily. Truth was never part of the training objective. 4 phenomena often confused. A hallucination is specifically a confident fabrication. An error is a mistake the model could have gotten right. Noise is statistical fluctuation. An adversarial attack is deliberate manipulation. Only hallucination describes polished output that simply isn't real. So the fingerprint is confident output combined with missing reality. When a scenario describes an AI producing a fabricated citation, quote, or case, that's a hallucination by name. Verify before trusting, especially when the output looks polished. Question 32. A hospital committee is reviewing the risks of deploying a generative AI tool for drafting clinical summaries for doctors. The committee wants to articulate why AI hallucinations are especially concerning in critical fields like medicine. Which statement best captures that central concern? Your options are A. They slow down server performance. B. They increase model training cost. C. They can lead to harmful decisions. D. They require additional GPU memory. Got a guess? Lock it in. The correct answer is C. They can lead to harmful decisions. C is correct because hallucinations present false information with confidence. In medicine, acting on a fabricated fact or citation can change a treatment decision, which is why critical fields must review AI output carefully. A is wrong because server performance concerns infrastructure rather than clinical safety. Even a fast, low latency system that hallucinates can still drive doctors toward incorrect choices, which is the true concern for the committee. B is wrong because training cost is an operational concern unrelated to patient safety. Hospitals worry about whether the generated content is accurate, not about how expensive the original model training process was. D is wrong because memory requirements are an engineering detail that does not drive clinical concern. The hospital worry is that false output can influence real care decisions regardless of hardware usage levels. Let's go deeper on why AI hallucinations are uniquely dangerous in medicine. It comes down to one idea: wrong facts become wrong decisions. 3 clinical use cases show the risk. A summary can invent a symptom, shifting the differential. A drug lookup can confabulate a dosage, shaping a prescription. A progress note can add facts the clinician never said. Each failure feeds directly into a real decision. This is the authority gradient. A hallucinated statement formatted like a real clinical observation carries the social weight of one until someone challenges it. Under time pressure, that challenge often doesn't happen and the false fact enters the record. The harm is steps removed from the hallucination, which makes it hard to trace. Since 2023, the field has responded in unison. The AMA and Joint Commission require physician review of AI-generated clinical content. Cleveland Clinic, Mayo, and Kaiser have invested in retrieval-augmented workflows that ground output in verified sources instead of letting the model free associate. On exam questions, distractors will mention server performance, training cost, or GPU memory. Those are engineering concerns. The fingerprint of the right answer is always downstream harm to humans. Stakes are the frame and patients are the reason. Question 33. A journalism instructor is teaching a class about how AI-generated content differs from deliberately created fake news and wants to explain the key distinction between AI-generated misinformation and disinformation. Which statement accurately captures that distinction for students in this course? Your options are: A. Misinformation requires image output. B. Misinformation is generated unintentionally. C. Misinformation uses third-party plugins. D. Misinformation needs adversarial inputs. Which one is it? Pause the video if you need more time. The correct answer is B. Misinformation is generated unintentionally. B is correct because misinformation is false content produced without intent to deceive, often as a hallucination. Disinformation, by contrast, is deliberately false content created and spread to mislead. Intent is the defining line. A is wrong because misinformation is not limited to images. Text hallucinations, fabricated quotes, and invented statistics are common forms, so the distinction does not rely on the format of the generated content. C is wrong because third-party plugins are not what defines misinformation. The key distinction between misinformation and disinformation concerns whether the false content was produced without intent or was deliberately spread to mislead. D is wrong because adversarial inputs describe deliberate attacks against models. Misinformation often arises from normal, well-intentioned prompts that happen to produce false output, without any adversarial manipulation entering into the process. Let's zoom out on the broader concept. This question is testing the difference between misinformation and disinformation. The entire distinction rests on a single word: intent. Same false content can land in either category depending on whether a human meant to deceive. Formal frameworks from agencies like SASA and researchers at Stanford treat these three terms precisely. Misinformation is unintentionally false. Disinformation is intentionally false. Malinformation is true information weaponized to harm. This is why AI-generated content is tricky. A language model cannot form intent, so its errors are misinformation. But a human who uses that same model to deliberately deceive has crossed into disinformation territory. On the exam, watch the verbs: unintentional, accidental, or hallucinated signals, misinformation. Deliberate, coordinated, or targeted signals, disinformation. Intent is the axis every time. Question theta. A product team wants to reduce AI hallucinations in a customer-facing assistant before launch. The team is evaluating several technical and process improvements they could adopt. Which approach is most likely to meaningfully reduce hallucinations in the responses the tool returns? Your options are: A. Shorten every user prompt. B. Disable all content filtering. C. Remove human review steps. D. Integrate curated trustworthy data. Take a second. Which answer would you pick? The correct answer is D. Integrate curated trustworthy data. D is correct because integrating curated, trustworthy data into training and retrieval reduces the model's reliance on noisy sources. Cleaner inputs directly lower the chance that the assistant will invent facts or false citations. A is wrong because shorter prompts are often more ambiguous, not less, and give the model less guidance. Forcing brevity usually increases the risk of incorrect or off-topic generation, rather than reducing it meaningfully. B is wrong because content filtering is a safety layer, not the cause of hallucinations. Removing filters would weaken the product overall and would not address the root reasons that models fabricate information. C is wrong because human review is one of the most effective defenses against hallucinations in critical outputs. Eliminating that safeguard would make errors harder to catch rather than preventing them before reaching users. So why does feeding curated data to an AI cut down on hallucinations? Let's look at the principle behind the fix. Language models hallucinate most when they have sparse information on a topic. Without grounding, the model fills gaps with plausible sounding guesses. Give it a verified passage and it stops guessing. It just paraphrases what's there. This is retrieval augmented generation. At query time, the system pulls verified passages from a trusted database and hands them to the model alongside the question. The model answers using those passages and often cites them directly. 3 techniques reduce hallucinations: curated training data, retrieval at query time, and human review. All 3 work, and the strongest production systems combine them, because each one catches different failure modes. The common thread is information density. More trusted data in the pipeline means less guessing. And less guessing means less lying. Grounded beats freewheeling every time. Question 35. A communications director is drafting messaging for a company that uses generative AI in customer-facing content and wants to explain to stakeholders why hallucinations are a serious ethical concern for trust. Which statement best describes that ethical concern in simple terms? Your options are: A. They erode user trust in output. B. They speed up harmless token generation. C. They shorten training epochs considerably. D. They lower server power consumption. Before I reveal it, which one do you think is right? The correct answer is A. They erode user trust in output. A is correct because hallucinations quietly undermine user trust in everything the system produces. Even a single confident falsehood teaches users to doubt later responses, which hurts adoption and the credibility of the product. B is wrong because hallucinations are not valued for speed or harmlessness. They generate confident false statements, so framing them around token generation speed entirely misses the actual ethical concern people raise with leaders. C is wrong because epoch duration is a development metric rather than a public ethics issue. Stakeholders worry about whether users can trust AI output rather than how long model training ultimately takes. D is wrong because power consumption is an operational efficiency concern, not a reason to worry about hallucinations. The core ethical problem is that false output damages user trust in the assistant's overall reliability. The deepest ethical concern with AI hallucinations isn't technical. It's trust erosion, slow, cumulative, and corrosive. Trust works asymmetrically. 1,000 correct answers don't prove a tool is reliable because accuracy is what we already expect. But one confident falsehood damages credibility far out of proportion to how often it happens. Trust erosion shows up in 3 layers. Individual trust, when a user stops believing a specific tool. Product trust, when they abandon the product entirely. And category trust, when skepticism spreads to all AI-assisted content. Gat say to make wait said, the most damaging, because no single company can contain it. The Google Bard demo in February 2023 is the textbook case. One factual error about the James Webb Telescope, caught live, erased roughly $100 billion in Alphabet's market value that day. One visible mistake can undo years of brand trust. So when the ethical concern is framed around communications, the honest answer is always trust. Not servers, not cost, not compute. Confidence is the currency, and hallucinations spend it faster than accuracy can earn it back. Question 36. A small design studio selecting an AI image generation tool for an upcoming brand campaign and is listing the most important features to evaluate across available platforms. Which key feature should be near the top of that evaluation list for image tools? Your options are A. Maximum storage capacity limit. B. Duration of daily use. C. Input method supported. D. Final rendered image price. What's your answer? Commit to one before I continue. The correct answer is C. Input methods supported. C is correct because input methods shape how designers can actually guide the model. Text prompts, uploaded sketches, reference images, and style samples each unlock different creative workflows and affect overall usefulness of the platform. A is wrong because storage capacity rarely determines a design studio's fit. Generated files are typically small, and most creative teams care far more about how expressively they can control the image output through prompts. B is wrong because daily duration caps are a licensing detail rather than a core creative feature. Studios prioritize how well a tool interprets their ideas, not the timer on how many hours they use. D is wrong because per image pricing is a business detail that varies by vendor and plan. It is not the primary feature studios weigh when judging whether a tool produces the desired creative results. When design studios evaluate AI image tools, one principle cuts through everything else. Input methods are the control surface. Here's why this matters. Visual creativity starts with visual material. A text-only tool forces designers to translate visual ideas into words, then back into visuals, losing information at both steps. 4 input modes define modern image tools. Text prompts are the baseline. Reference images guide style. Sketches and masks control specific regions. Iterative feedback enables real back and forth. A tool supporting all 4 matches how designers actually work. On exam questions, watch for distractors about storage, pricing, or usage duration. Those are commodity concerns. The professional answer is always about input methods and control. Control is the product. If a question asks what makes an image tool useful for design work, the answer is the input methods, the ways it accepts creative direction. Question 37. A marketing associate is learning to write image generation prompts and is compiling simple guidelines for teammates who are new to the tool. Which specific guideline should be followed when crafting a prompt to generate an image using AI in this way? Your options are: always skip descriptive language. B. Avoid multiple long sentences. C. Offer many alternative options. D. Start with the target audience. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is B. Avoid multiple long sentences. B is correct because image models respond best to concise, descriptive prompts rather than long paragraphs. Compact phrasing helps the tool lock onto the subject, style, and mood the associate wants to see. A is wrong because descriptive language is exactly what guides image models. Strong adjectives and specific nouns help the tool choose colors, composition, and lighting, so eliminating description would leave the prompt underspecified and vague. C is wrong because offering many alternatives confuses the tool. Mixing mutually exclusive options in a single prompt causes the model to blend conflicting styles, rather than commit to one clear creative direction overall. D is wrong because image prompts center on the visual subject, not the target audience. Audience matters when writing copy, but an image tool needs scene, style, and mood cues rather than viewer demographics. Why do short prompts beat long ones when generating images? The answer lies in how these models actually read your words. Every word in a prompt pulls the generation in some direction. More words means more pulls, and conflicting pulls cancel each other out, producing muddier, less focused results. Here's the core reason the rules differ. Text models track long sequences of instructions easily, but diffusion image models cap their text encoder at roughly 75 tokens. Anything beyond that gets truncated or weakened. Strong prompts share three qualities: specificity, weathered, not old; compression, stacked descriptors, not full sentences; balance, subject, style, and mood without overloading any one dimension. Short and vivid beats long and vague. Professional prompts read like poetry, dense, specific, and compact. Brevity is the discipline, and every word should earn its place on the canvas. Question 38. A person wants to generate an image for a social media post about competitive road cycling and wants the image to show cyclists sprinting at a finish line. However, the person uses the prompt means road cycling and gets an undesirable result. What is the problem? Your options are: A. The prompt omits the purpose. B. The prompt is totally irrelevant. C. The prompt lacks a subject. D. The prompt lacks specificity. Which would you go with? Lock it in before the reveal. The correct answer is D. The prompt lacks specificity. D is correct because the short phrase leaves the tool guessing everything except a general theme. Specific details like a sprint finish, crowd, and close framing would steer the model toward the desired sports image. A is wrong because purpose is not the missing element, even without stating that the image is for social media. More descriptive cues about the visual scene would have improved the output clearly. B is wrong because the prompt is on topic rather than irrelevant. It names the correct category of cycling but fails to describe the specific moment, setting, and composition the person wanted the tool to depict. C is wrong because the prompt does include a subject, namely road cycling. The missing ingredient is specificity around the scene, such as action, viewpoint, and setting rather than a subject noun being absent entirely. Let's talk about why vague image prompts fail and what makes a prompt actually work. When you give an image model only a general category, it fills in everything else by guessing. It picks a statistical average from its training data, which almost never matches the specific picture in your head. 4 dimensions usually matter: subject, action, setting, and mood. Name the subject but skip the action, and the model invents an action. Cover all 4, and you constrain the output close to what you actually wanted. This isn't creativity on the model's part. It's conditional generation. Each specific detail you add narrows the pool of training examples the model draws from, pulling the output closer to your intended result. On the exam, if a prompt names a topic but produces generic output, the answer is lack of specificity. Detail is the fix, and detail is what separates amateur prompts from professional ones. Question 39. A person is creating a brochure for a local farmer's market and wants to use generative AI to create a farm-related background image for the layout. Which prompt engineering solution is most effective for achieving the intended result in this situation? Your options are: A. Indicate the purpose of the picture. B. Be concise with a single keyword. C. Use a long chain of reasoning. D. List the number of stalls. Don't overthink it. Which one feels right? The correct answer is A. Indicate the purpose of the picture. A is correct because naming the purpose, like a brochure background for a farmer's market, gives the tool context. Purpose cues help the model choose composition, color, and mood that fit the intended use. B is wrong because a single keyword leaves too much unsaid. Image models need enough descriptive cues to lock onto subject, style, and atmosphere. So ultra-short prompts commonly produce generic or off-theme results. C is wrong because long reasoning chains are useful for text or math tasks, not image generation. Image tools respond better to concise descriptive prompts than to step-by-step argument about what should be drawn. D is wrong because stating how many stores appear is an arbitrary detail rather than a prompt engineering solution. The strongest improvement is telling the tool the use case so it frames the scene appropriately. Here's the single most powerful lever in image prompt design, naming what the image is for. Good design starts from use. A brochure background, a social thumbnail, a print poster. Each has different needs for composition, density, and color. When you name the purpose, the prompt becomes a brief, and briefs produce work that actually fits. 3 things flow downstream from purpose. Composition leaves space for titles or logos. Color palette aligns with the surrounding brand context. Level of detail balances interest against readability at the intended size. None of these improve when only the subject is named. The mechanism is simple. Image models learned associations between visual styles and specific purposes from millions of captioned examples. Name the purpose and the model pulls from those conventions. Omit it and the output has nothing to anchor to. So on the exam, when distractors offer keywords, reasoning chains, or arbitrary details, remember use case is the frame. Purpose shapes composition in ways the subject alone never can. Question 40. A nonprofit is discussing the ethical issues surrounding AI-generated images in its public campaigns and wants to name the most widely cited ethical concern about these images in current media and legal commentary. Which concern is most directly associated with them? Your options are A. Reduced GPU availability, B. Higher carbon footprint, C. Unclear copyright ownership, D. Difficulty printing grayscale. Got a guess? Lock it in. The correct answer is C. Unclear copyright ownership. C is correct because generative image tools raise ongoing questions about who owns the output and whether training on copyrighted material infringes on creators' rights. Courts and lawmakers are still working through these issues. A is wrong because GPU availability is a technical resource concern rather than an ethical issue. Most discussions of AI image ethics center on authorship, consent, and potential misuse rather than hardware supply at all. B is wrong because while energy use is a real topic, it is not the most widely cited ethical issue in media commentary on AI-generated images. Copyright and authorship dominate the public debate today. D is wrong because grayscale printing is a production detail, not an ethical concern. Campaigns routinely handle color conversion as part of normal design work, independent of any ethical questions about AI-generated images themselves. Let's go deeper on why copyright dominates the ethics conversation around AI-generated images. The debate splits into 3 distinct questions. Can models train on copyrighted art without permission? Can AI-generated outputs be copyrighted at all? And does mimicking a living artist's style count as infringement even without copying a single image? Landmark cases like Getty, Images versus Stability AI pit rights, holders against model providers. Artists say training without a license is infringement. Model makers say it's transformative fair use. Courts have issued preliminary rulings, but the core question remains open. In 2023, the U.S. Copyright Office ruled that purely AI-generated works can't be copyrighted, which blindsided much of the industry. With litigation still active and workflows being rebuilt, the unresolved legal status is exactly why copyright dominates the space. So when an exam asks about the leading ethical concern for AI-generated images, ignore distractors like GPU supply or energy use. The honest answer is copyright, authorship, and ownership. Question 41. A data team is preparing training materials about natural language processing and wants to give colleagues a concrete example of an everyday activity that NLP directly facilitates inside typical enterprise workflows. Which activity best fits that description in this kind of training? Your options are A. Verifying experiment measurements, B. Removing duplicate text data, C. Managing parallel computing jobs, D. Calculating numerical data statistics. Which one is it? Pause the video if you need more time. The correct answer is B. Removing duplicate text data. B is correct because natural language processing handles tasks involving text, including deduplication. NLP can recognize near duplicate phrases even when wording differs slightly, which makes cleaning text datasets more accurate than exact matching. A is wrong because verifying experiment measurements is a scientific and statistical activity. NLP focuses on understanding and producing language rather than validating numerical readings from sensors or laboratory instruments used in experiments themselves. C is wrong because managing parallel computing jobs is an infrastructure task. Distributed computing systems handle it through schedulers and orchestrators, not through natural language processing techniques that work primarily on human language data. D is wrong because calculating numerical statistics is the job of analytics libraries and statistical software. NLP enters only when language descriptions of the results need to be generated or summarized for readers. Let's zoom out and talk about what natural language processing actually is, and why deduplication belongs to it. NLP is the branch of AI that takes human language as input, output, or both. If a task is about understanding or cleaning text, NLP is the right tool. If it's about numbers or infrastructure, it isn't. 3 NLP use cases show up constantly on this exam. Deduplication collapses repeated information. Classification sorts text into categories like positive or negative sentiment. Extraction pulls specific facts out of longer text. All 3 require understanding language, not just matching characters. Here's the mechanism. Modern NLP turns each piece of text into a vector, a list of numbers that captures meaning. Texts that mean the same thing land close together in vector space, even when spelled differently. That's how NLP catches paraphrased duplicates that simple string matching never would. So on exam day, if the task is cleaning, sorting, summarizing, or classifying text, the answer is NLP. If it's measurement, statistics, or compute jobs, it's not. Deduplication fits the pattern cleanly. Question 42. A retailer is modernizing its paper coupon program and wants to digitize and validate paper coupons that customers bring to the register, converting the printed codes into structured data for internal systems. Which advanced AI tool is best suited for this task? Your options are A. Virtual personal assistant, B. Voice recognition, C. Speech synthesis, D. Optical character recognition. Take a second. Which answer would you pick? The correct answer is D. Optical character recognition. D is correct because optical character recognition specializes in reading printed or handwritten text from images and converting it into machine-readable data. Paper coupons are exactly the kind of document OCR was designed to digitize. A is wrong because a virtual personal assistant coordinates conversations, reminders, and tasks. It might use OCR under the hood, but the specific capability needed for digitizing printed coupons is text extraction from images. B is wrong because voice recognition converts spoken audio into text or verifies speaker identity. Retail coupons exist as printed paper, not speech, so a tool focused on audio is not the right match here. C is wrong because speech synthesis generates audio output from text for voice assistants and accessibility tools. The retailer's task flows the opposite direction, converting printed text into data, which is a specialty of OCR. Let's talk about OCR. Optical character recognition, the AI capability behind turning printed text into digital data. The core idea is simple. OCR takes printed or handwritten text inside an image and converts it into a machine-readable string. Paper in, data out. Under the hood, modern OCR combines two neural networks. A detection network finds where the text is in the image, and a recognition network reads each region character by character, producing the final digital string. In retail, you'll see OCR everywhere, reading checks at banks, turning receipts into expense reports, digitizing paper forms, and validating coupon codes at the register. Same capability, different documents. So when a task involves converting printed text on paper into digital data, OCR is the tool every time. Voice and assistant tools live in other lanes. Text extraction belongs to OCR. Question 43. A building security team wants to use AI to recognize a person's identity by having them speak their name into a microphone at an entry point, and the team needs to select the specific advanced AI tool that performs this kind of task. Your options are A. Voice recognition, B. Object recognition, C. Text recognition, D. Speech recognition. Before I reveal it, which one do you think is right? The correct answer is A. Voice recognition. A is correct because voice recognition identifies a speaker based on unique vocal characteristics. Security systems use it to verify that the person speaking matches an enrolled voice print, which fits the entry point authentication use case. B is wrong because object recognition identifies physical items within images or video. Recognizing a person by spoken name requires analyzing audio patterns, which falls outside the scope of vision-focused object recognition systems entirely. C is wrong because text recognition extracts written characters from documents or images. The security task hinges on identifying a speaker's voice, which text-focused techniques cannot accomplish because there is no printed input here. D is wrong because speech recognition converts spoken words into text, but does not verify who is speaking. The entry point needs speaker identity, which is the specialty of voice recognition rather than transcription systems. Let's unpack the technology behind voice recognition and why it's the right answer for identifying a person by how they sound. Every person's voice has unique acoustic patterns, pitch, tone, cadence. Voice recognition treats those patterns like a fingerprint, asking who is speaking rather than what they said. Under the hood, deep learning maps each voice sample into a compact embedding. Enrollment stores your voice print. Verification compares a fresh sample against it. If they're close enough, you're in. The same core technology powers 3 applications: access control at secure entry points, phone-based account verification at banks like Chase and Wells Fargo, and forensic identification in law enforcement. So when an exam question involves identifying a person by their voice, the answer is voice recognition. Speech recognition is the close but different distractor. Identity versus content. Question 44. A vendor is explaining to a customer what specifically makes voice recognition unique compared with other similar audio-focused AI applications. And the vendor wants a crisp distinguishing statement that clarifies the difference for business decision makers evaluating several tools for workflow needs. Your options are A. It enables automated data entry. B. It enables virtual assistant technology. C. It enables verifying a speaker identity. D. It enables processing of physical documents. What's your answer? Commit to one before I continue. The correct answer is C. It enables verifying a speaker identity. C is correct because voice recognition is specifically about authenticating who is speaking, not just understanding what they say. This identity verification capability sets it apart from transcription-focused tools that only convert speech to text. A is wrong because automated data entry is a common outcome of OCR and form processing tools. Voice recognition may contribute to dictation workflows, but the distinctive feature is speaker identity rather than entering data. B is wrong because virtual assistant technology combines several components, including speech recognition and dialogue management. That broader capability relies on transcription, which is not what uniquely defines voice recognition among audio tools here. D is wrong because processing physical documents is the domain of OCR and document AI. Voice recognition deals with audio, so physical paperwork falls entirely outside the scope of what it is built to handle. Let's go deeper on why voice recognition stands apart from other audio AI tools. The key idea is simple but easy to miss. Voice recognition asks who is speaking. Speech recognition asks what was said. Identity versus content. That single distinction is the whole concept. Under the hood, the two systems work very differently. Speech recognition maps sound patterns to phonemes and then to words, producing a transcript. Voice recognition maps any voice sample to a person-specific vector, producing an identity match against the database. In the real world, dictation tools like Otter and Dragon use speech recognition. Bank phone authentication uses voice recognition. Voice assistants use both, first identifying who is speaking, then transcribing the request. So when a question asks what makes voice recognition unique among audio AI tools, the honest answer is speaker identity verification. Authentication is its specialty, and that sits cleanly apart from every other audio capability. Question 45. A small nonprofit is trying to select the right kind of AI tool for a specific internal use case and wants a practical principle to guide that selection. Which principle most usefully guides choosing between OCR, voice recognition, and natural language processing? Your options are: A. Always pick the newest tool. B. Always pick the cheapest tool. C. Always pick the largest model. D. Match the tool to the task. Pick one. Trust your gut. Here's your chance to test yourself. The correct answer is D. Match the tool to the task. D is correct because each advanced AI tool has a specialty. OCR reads printed text, voice recognition authenticates speakers, and NLP processes language. Matching the tool to the actual task drives the best results. A is wrong because newer tools are not automatically better fits for every task. A mature, specialized model often outperforms a newer general-purpose one when the problem calls for a specific capability and domain knowledge. B is wrong because cheapest does not mean most appropriate. Low-cost tools may lack the specific capability the nonprofit needs, so fit must come before cost in the decision process for selecting tools. C is wrong because larger models are not universally superior for every task. A smaller model targeted at the specific job often delivers better accuracy and lower cost than a general-purpose giant applied bluntly here. So why does matching the tool to the task matter so much? Let's look at the principle behind this answer. Specialist AI tools are trained on data specific to one job. OCR reads printed characters, voice recognition authenticates speakers, and NLP works with text. Each is excellent inside its lane and weak outside it. Specialists win on narrow tasks because their training data is concentrated there. A small mature OCR model has seen millions of printed characters. A giant language model has seen a little of everything, and its accuracy on narrow tasks reflects that. That's why the three common shortcuts fail. Newest lacks track record, cheapest lacks capability, and biggest is slower and more expensive without being more accurate. Only task fit selection reliably works. Capability to task alignment is the discipline that separates teams getting real value from AI from those wasting budget. When in doubt, match the tool to the task. Question 46. A sociologist has collected a large amount of data about group interactions on social media and wants to use generative AI to help visualize the data clearly. Which step should most likely be taken first when prompting the AI model in this workflow? Your options are: A. Create a histogram first. B. Clean the data by removing outliers. C. Input data using multiple formats. D. Calculate basic statistical summaries. Which would you go with? Lock it in before the reveal. The correct answer is B. Clean the data by removing outliers. B is correct because cleaning the data removes noise that would distort any visualization. Outliers can dominate axes or charts, so handling them first gives the generative AI a stable foundation to build from. A is wrong because creating a histogram is a specific visualization choice, not a preparation step. The sociologist must first ensure the underlying data is clean so that any histogram produced afterward is actually meaningful. C is wrong because multiple formats introduce complexity before the basics are handled. Consolidating and cleaning data first produces a more reliable input for any generative AI visualization tool applied afterward. D is wrong because calculating statistics before cleaning can produce misleading summaries. Outliers and missing values skew averages and spreads. So cleaning first ensures downstream statistics and visualizations reflect the real distribution accurately. Let's talk about why data cleaning always comes first in any visualization workflow, whether or not AI is involved. 3 distortions sabotage visualizations built on dirty data. Outliers compress normal values into a thin band. Null values get interpreted inconsistently across tools, and encoding errors create phantom categories from inconsistent formats. John Tukey established this order at Princeton and Bell Labs in the 1960s. Check outliers, understand them, decide what to do, then analyze. Generative AI inherits these rules intact. It just executes each step faster. Here's the key insight. An AI asked to visualize dirty data produces a faithful visualization of the dirt. The AI is an accelerator, not a replacement for analyst judgment. Clean first, visualize second. Preparation precedes presentation in every serious data pipeline. That's the honest first step. Question 47. A scientist wants to use generative AI to sort a large dataset about weather patterns across multiple regions, and the dataset contains some gaps in the original sensor readings. Which step should be completed before attempting to sort the full dataset? Your options are: A. Handling missing values. B. Defining a single criterion. C. Identifying key trends immediately. D. Creating a final visualization. Don't overthink it. Which one feels right? The correct answer is A. Handling missing values. A is correct because missing values can confuse sorting logic and skew the resulting order. Filling or flagging gaps before sorting ensures the generative AI processes a complete, consistent dataset rather than an incomplete sample. B is wrong because sorting often requires multiple criteria such as region, season, and severity. Reducing to a single criterion upfront would limit generative AI and ignore the richness of real datasets. C is wrong because identifying trends usually happens after the data is organized and cleaned. Jumping to trend analysis on an incomplete dataset risks patterns that are really artifacts of missing or bad values. D is wrong because visualization belongs near the end of a workflow, not before sorting. Preparing a final visualization on raw data with gaps would misrepresent the weather patterns instead of revealing them clearly. Before you sort, filter, or model anything, you have to deal with missing values. Skipping this step hands control of your analysis over to whatever default your tool happens to use. Statistician Donald Rubin gave us 3 categories of missingness, completely at random given what we observe, and not at random, where the gap itself depends on the missing value. Each type calls for a different handling strategy. In practice, 3 approaches dominate. Deletion is simple but throws away data. Imputation preserves rows but adds assumptions. Flagging keeps the information that something was missing, which can itself be meaningful. Serious analysts pick the right tool for the problem. Sorting imposes a total order, so every record needs a position. Missing values force the tool to invent one, and that default rarely reflects reality. A temperature sort with offline Alaska stations could put them first or last for no meaningful reason. So the honest first step is always handling missing values. Gaps create undefined behavior in every downstream operation, and cleaning them up is what makes everything that follows trustworthy. Question 48. A data analyst is explaining to executives why generative AI has become a valuable data sorting tool compared with earlier scripts and rule-based approaches, and needs to name the single capability that most clearly makes generative AI useful for sorting tasks today. Your options are: eliminating measurement errors automatically, B. Identifying potential ethical concerns, C. Categorizing data into predefined groups, D. Removing sampling bias from inputs. Got a guess? Lock it in. The correct answer is C. Categorizing data into predefined groups. C is correct because generative AI can quickly place records into predefined categories based on patterns in the content. That classification capability is the core reason it is useful as a sorting tool today. A is wrong because eliminating measurement errors is the job of careful instrumentation and data validation. Generative AI may help flag suspicious values, but removing measurement bias is not what makes it a sorting tool. B is wrong because identifying ethical concerns is a reviewer responsibility supported by AI rather than a sorting capability. The specific value of generative AI for sorting is how it classifies records into clear groups. D is wrong because removing sampling bias requires better data collection practices, not a sorting algorithm. Generative AI can reveal bias during exploration but does not eliminate it simply by sorting existing records into groups. Let's dig into why generative AI is so powerful as a sorting tool. The answer comes down to one capability: flexible classification. Older rule-based systems required explicit criteria, keyword lists, regular expressions. If this then that logic, generative AI instead reads each item, understands what it's about, and assigns it to a category based on meaning rather than surface patterns. You see this everywhere in business, routing customer feedback into billing or technical buckets, filing contracts and invoices, and tagging catalog items into taxonomy nodes. All 3 tasks share one shape: read content, understand it, assign a predefined label. Here's the core mechanism. A complaint about being overcharged might say bill, invoice, fee, cost, or price. Rules need every variant spelled out. A generative model recognizes they all point at the same concept and routes the ticket to billing regardless. So when an exam asks what makes generative AI valuable for sorting compared to rule-based scripts, the answer is flexible classification into predefined categories, pattern-based grouping by meaning, not by string match. Question 49. A doctor wants to analyze a large data set for research about a specific disease treatment outcome, and is thinking about how generative AI could meaningfully contribute to the analysis without replacing the doctor's own judgment throughout the process. How can generative AI help? Your options are: A. By highlighting legal concerns first, B. By building an interactive database, C. By adjusting values for higher precision, D. By suggesting appropriate visualization techniques. Which one is it? Pause the video if you need more time. The correct answer is D, by suggesting appropriate visualization techniques. D is correct because generative AI can look at a dataset's shape and recommend useful visualizations. Scatter plots, heat maps, and survival curves may all emerge as options, leaving final selection to the doctor. A is wrong because highlighting legal concerns is the job of compliance officers and institutional review boards. Generative AI can support those reviews, but typically does not lead a clinical research analysis with legal commentary. B is wrong because building an interactive database is infrastructure work performed with dedicated tools. Generative AI might help draft queries or interface text, but spinning up a database is not its analysis contribution here. C is wrong because silently adjusting values to increase apparent precision is a red flag for data integrity. A trustworthy AI assistant does not inflate precision or alter measurements without a clear documented reason. Let's zoom out and look at the underlying principle behind this question: how generative AI can genuinely help a clinician without replacing their judgment. Think of generative AI as a skilled illustrator sitting next to the researcher. It has read thousands of scientific papers, so it knows which charts suit which data, but it never claims to understand what the chart means clinically. In medical research, generative AI typically contributes in three assistive ways: recommending chart types for the data structure, guiding layout of panels and axes, and drafting captions and legends. All three speed up production work without touching interpretation. The key pattern is a clean division of labor. The AI handles visualization reasoning drawn from statistical writing it was trained on. The human handles clinical reasoning. Keeping these separate is what makes the workflow responsible. So on the exam, watch for answers framed as support rather than authority. Visualization suggestions help. Legal review, database building, and value adjustment are distractors. Support is the frame and judgment stays with the human. Question 50. A chief data officer is comparing generative AI to purely rule-based sorting scripts and wants to summarize the primary advantage of using generative AI for data sorting work across evolving business context and data sets. Which summary captures that primary advantage most accurately? Your options are: A. It adapts to evolving context. B. It removes need for schemas. C. It prevents all data loss events. D. It simplifies data center hardware. Take a second. Which answer would you pick? The correct answer is A. It adapts to evolving context. A is correct because generative AI can infer, organize, and optimize data even when criteria shift across departments, seasons, or customers. That adaptability goes beyond static rules and suits business environments where context changes regularly. B is wrong because generative AI does not remove the need for well-designed schemas. Clean structure still matters for reliability and governance, and generative tools perform better when the underlying data is schema-aware. C is wrong because no system guarantees prevention of every data loss event. Backups, redundancy, and access controls mitigate loss, and adding generative AI to sorting does not change those infrastructure protections. D is wrong because data center hardware simplification is unrelated to sorting quality. Generative AI typically adds compute demand rather than reducing it. So hardware simplification is not a benefit this technology actually delivers here. So why does generative AI actually outperform rule-based scripts for sorting data? The answer comes down to one word: adaptability. Think of rule-based sorting like a printed map. It captures what someone knew at one moment in time. When the roads change, the map becomes wrong and someone has to redraw it by hand. Here's the core contrast. A rule-based system encodes fixed criteria and needs a developer every time the world changes. A generative system infers criteria from the current data and intent, adjusting as context shifts. Three contexts where this matters most: seasonal shifts that change priorities across the year, product launches that need new categories on the fly, and market changes that reshape what counts as important overnight. So remember, rules age, contexts shift, and generative AI is the approach built to keep up. When an exam asks for the primary advantage over rule-based scripts, adaptability is the honest answer.
You have reached the end of our first question set. For the free complete exam preparation, visit our website link in the description, where you find thousands more practice questions and comprehensive study guides. Thanks for studying with us today. See you in the next video.